Well, good morning, everybody. Thank you, Dominic. Thank you, Christabel, for that excellent introduction. I also want to thank DP and Thomas for inviting me to join you all here today. It is a pleasure to be connecting with all of you to talk about what's going on in the world that we all love, which is technology. As Dominic noted, I've been in this space for over 40 years, but IDC, the company that I work for, was founded over 60 years ago with the motivation of understanding how companies were adopting technology. At that time, it was, where are all the mainframes? Now, when I joined a little bit later in the mid-'80s, we were beginning the PC networking area, and I do remember I was the modem analyst. So that was the technology I was dealing with. And I remember this interesting conversation with a senior technology leader from a major modem company, Hayes, some of you may recall them, who said, nobody needs a 9600 baud modem because you can't type that fast. Now, I took away from this a very clear message that any predictions about the future and where things are going by technology leaders should always be taken with a bit of a grain of salt. And I always try and do that when I'm talking through this as well. Now, I've gone through many different technology waves, just like all of you in the room. And I think I would note that the reason we're all here today is that all of you, the companies you've supported, the systems you've supported for your companies as we've adopted client-server and web and cloud and all the other things, it's because you all did a fabulous job of making sure that companies could use all that technology. But we're at a new phase now where we have to talk about the next new pivot for technology that's going to shape what we all do, which is AI. And so I want to deal with you and give you some insights on what we've seen over the last year and where we see things going over the next year. I'm not going to get into, artificial general intelligence and when they take over the planet. That's not my job. But I want to talk about what we need to do to succeed and make sure that our companies are taking advantage and using AI effectively over the next few years. So I'm going to leave you with three simple things. When we talk to CIOs, we talk to business leaders, and we hear what they found that was important for them to succeed, they've highlighted that for the next few years, our focus, we have to be, as I would say, focus, ensure consistency, and always think about the challenge of scale. Now, why that's happening is because when we go back and look at what happened in 2024, we saw a very clear story about there was a lack of focus. And we saw this as summarized as the proof of concept trap. There was a recognition that there was an amazing amount of inconsistency in the tools and the models and the data and the apps that we were looking at for AI. And that there was time and time again, even where we thought we had something good and was successful, when it came time to scale, either it was too expensive or we just couldn't get access to the technology where we needed it to do it effectively. And this, for us, is the next big challenge that's going to play out here. Now, let's go look at a little deeper into each of those. So first, let's look at the proof of concept trap. So we actually do track this. I happen to own a survey we do every month of about 1,000 IT leaders around the world. And we wanted to see where were we on this whole stage. Now, late 2023, early 2024, companies had walked in with hundreds of use cases. A lot of enthusiasm from employees around the company, all businesses, all sectors, all tasks. Say, hey, let's do these things. Let's use Gen AI to change what we do here. In general, on average, a typical enterprise ended up doing about 37 proof of concepts. And as we checked in July, sort of halfway through the year, all right, only about 37% of those had kind of made it to the successful stage where we're going to try and convert them into production. We went back in January, so just a few months ago, and asked the same question, and the results were a bit underwhelming. You would think after another 6 months, we weren't shooting for 100%. That's never what you would expect. But it would have been nice if it had gotten above 44%. And when we highlighted what were the things that were limiting this and what was basically preventing people from doing it, we saw that they really fall into two groups. One is IT leaders, business leaders continue to be focused and concerns around data. Can I trust that this data has been interpreted correctly? Can I trust that I am not losing, sort of giving away intellectual property? Can I trust that somehow or another it's not being perverted and used and sort of creating an hallucination that's going to affect my brand? That was one. The other side was the cost, as we noted. It's just too expensive to get this infrastructure up, or the amount of money I had to spend on the models and platforms to make that work. All a significant issue. Now, one thing that people always ask is, well, okay, that was building your own custom apps. That was your Gen AI model products. What about when you adopted something like Copilot or some of the various, tools that were coming out, Gen AI tools from major software providers that allowed you to do things? And how successful were those? And the data was a little bit better. It's like we got to half of all of those have been successful or have been successfully converted. But not great. I mean, you would like it to be better than that. And the thing that became clear is that the heightened concern around the loss of control of our data, or that somehow or another that how this comes out, we're losing the ability to set the agenda and protect our brand, was a major barrier for why people would take this forward. We saw again and again, people said, like, internal-facing apps, great. We can put them into production. If it's customer-facing, no, we need to take a little more time. We really need to be verified. They just couldn't make that leap. But we also saw very early, and it's starting, is a lot more concerns about the cost associated with those third-party apps. Can I really align that cost with value? And do I have the ability to understand that? So those were the big concerns here. What all this is that we're really talking about, the last year has been a Gen AI scramble, is that people have these different tasks, like where do we do with our data, what's the application, what's our governance policy, how are we even going to train people on how to use this? Do we have money to do that? It's been all over the map. There hasn't been consistency or thinking about consistency. It really plays out there's really application we all know about, but the main ones have really been AI platforms. So I've got all these different tools and models. How do I use them? Where do I get them from? The data and the data processes and rules that allow me to use that data. And then ultimately the infrastructure. What's the tools, what's the systems underneath that allow me to use all that? And this is where we see across the board inconsistency and inability to scale is a constant battle. Now, when we think about the other side of this, though, we note that for a lot of companies, it really came down to governance. And what was interesting is we actually did the research, and people would always say, oh, well, regulated companies would have a harder time adopting Gen AI. We actually found it was the opposite. And it's because regulated companies already had existing data governance practices in place. Now, they may not have been perfectly aligned with AI needs, and there was work to do there, but they had something to start with. They had a foundation of processes and people and technologies. Unregulated companies were just more and more likely to be overwhelmed. And that was a big challenge and something we saw as well. So it's often overlooked, but for many companies, this was the biggest barrier to truly getting to that next phase. Now, when we put together companies, we take it across the board, and I would say this for all of you in this room, if we did a survey of your companies, what we would note is probably about a third of you and your companies are what we would call frozen in fear. That even if things look good, even if things seem reasonable, we just can't pull that trigger because we are so worried about the data concerns and the brand concerns. About 15% said, hey, we have the confidence in our data, we have the confidence in our systems. Our big thing, we're ready to go. We just have to find better solutions that allow us to scale quickly and help us do that more effectively. But for most of us, and half I'd say in the room here, is your company is standing there on the edge waiting to take the leap. And we're saying 2025 is when we're going to do that. Now, before we take that leap, though, I do feel like I have to step back and note that there is another problem. It's the IT industry itself. And I'm speaking up here as part of that, have been part of it. If we look at what's the industry that's most rapidly pivoted to incorporating AI into its business plans and its strategies and its technology development and its marketing, it's the IT industry. So we've talked about the industry AI pivot. It's not everybody, not all the same, but it has definitely become a major part of every conversation. And what had happened for you, I'm going to acknowledge, we've heard this from many CIOs, is great. We had a strategic partner, we were ready to do a plan, we'd picked a software thing, they just got bought by somebody who's not our strategic partner. Now we have to go rethink our whole strategy. How do we do this? It's been something where that lack of confidence in a partner long term, especially when you're dealing with startups or large companies, is a challenge. The second part of it is, okay, infrastructure, that's also a thing. We can't predict what our infrastructure costs are going to be as much as we would like to. People are changing the rules. People are changing the licensing policies. How we get access to new technology is changing. That's not something that makes our life easier. Please stop doing that. And the last is we definitely acknowledge that the sales teams, the go-to-marketing teams, whether it's in services, it's products and softwares, they are very happy to tell us how we can use our great technology to do 5, 10, 20 use cases, and then we'll figure out how we do it because now we want you to use them together. But what we hear again and again is people said, well, these were great proof of concepts. They worked out really well, but 2 months later, nobody was using the tool anymore because we didn't bother, and the people helping us develop didn't help us do the work to help train our employees on how to take advantage of the technology. And that's never a good story. So one thing here we are, as you go out in the coming year and you're looking at your AI partners, the technology providers are going to help you make this AI, try and figure out where they play in this. How effectively are they helping you solve the issues versus being part of the problem? Now, that's where we were. Now let's talk about what all of the organizations are doing now. Where are they focused? So we went out in that same survey, and actually we did this in December, so it was a good time from a budget standpoint to understand where people were, and said, okay, where are you planning to increase your spending the most in the coming year? Now we have AI separately, so we'll keep that off the list for now. But what we saw were some very interesting things. So first of all, let's focus on modernizing our applications. That's a high priority. Let's modernize our corporate data centers. In fact, in the US, that was the top priority, was modernizing corporate data centers. The other ones now were enhancing our resiliency, our cyber recovery. This was the top budget spend in Europe. And then finally, for many companies around the world, there continues to be this, let's migrate some of our applications to a cloud model, whether that's SaaS or moving it to infrastructure. That was particularly top of the list in Asia Pacific region. But across the board, they're all here. What I took from this, and when we saw this, is everybody likes to talk about what's the word of the year for the coming year. And in 2024, it was clearly innovation or experimentation. But it was clear as we walked in that CIOs and businesses said that we would like 2025 to be the year of modernization. That we've learned a lesson from 2024 that to do these things right, to be focused, to be consistent, to drive scale, we really got to get our underlying systems that are already in place that our company is based on in a much more modern, updated, scalable fashion. And we want to spend our money doing that. That's what we'd like to be spending our money on in 2025. Now, why did they want to do that? What were the underlying factors that drove that? Again, some interesting insights here. So think about the top, 4 and 3 on this list, going from bottom to top, but the most important was improving the resiliency of the organization and understanding and recognizing that more and more of their new apps actually require more performance, more scale, more capacity than they really have in their existing environments. So we got to improve that. Not a surprise in some levels, but I will tell you this actually ended up being a big surprise, is preparing for the greater use of AI in the business, finished at number 2. When we actually did the same survey in September, it was at number 1 at around 45%. But what had come up now was, and this was the big increase, was reducing IT operating costs. Now, it is clear that we saw at the same time we were doing this survey that people increasingly understand that 2025 might be kind of an uncertain year for the economy and for the world. And that while we're not going to change our plans, we have to start thinking and preparing for that uncertainty. So I do want to say that's something that's coming through here. What I would summarize from this, though, is if you look at all of these, you look at 4, 3, and 1, the common thing here that we see people want is observability. They need more insights into what's going on in their systems, whether that's, are we more resilient as a business? Are we exposing ourselves? Are we actually able to monitor the performance and the operations of our platforms? And of course, are our costs actually in control and other pieces? But I would actually note that even number 2 on AI expansion is about observability. Because one of the things we absolutely said, part of this consistency is predictability in cost. And the best way to have some predictability in cost to start with is at least to know what you're actually spending and where it's going. So having observability across the board is, we think, is a high priority here. Now let's delve more into AI in particular. So this is from the same group of people, what's your AI budget for 2025 and 2026? So you can see here, on average, this is for companies with 1,000 and more employees around the world. So it's not small business, let's say. Good numbers, and actually this is up about 100% from 2024. Now, the other thing I'm going to tell you right though is this isn't just Gen AI, this is all AI. This is for your predictive systems, your machine learning systems, whatever. And as a matter of fact, a majority of most companies' AI budget today remains not Gen AI and all these new things, but it's those existing systems. Because really, AI has been embedded into businesses for more than a decade. However, it's been fragmented. It's very narrow systems focusing on very specific tasks and very specific business units. One of the tasks that we see that's part of this goal on consistency is we need investments that allow us to actually maximize the value of those existing AI assets and systems, but allow them to start being useful for a broader range of people inside the organization. And what I would say here is what that came down to, when we talk across the board, no matter where you are on your AI journey today, it's absolutely going to be increasing as a part of your spend in the next couple of years. But the way we like to think about it is that AI is becoming the next strategic workload for most enterprises. Just like ERP was in the 90s, just like e-commerce systems were in 2000s, mobile and cloud systems were in 2010s, this is the area where more and more companies recognize that while we have made AI everywhere, that now we have to make the ability to use AI systems and the data that's extracted by AI systems is one of our basic corporate muscles. And that means a much more focused view on how we make investment decisions for the underlying technologies, that we recognize that these have to be built for scale, and that consistency is the key to allowing us to get the maximum benefit out of it. So here we are, 2025, let's move on to this next stage of adoption. Again, hear what we say. The winners, we believe, in the next phase, the next year, are those who focus on processes and make sure that they are understanding at a business level and an IT level where that's going to play out, that they've adopted practices and solutions that allow them to basically be consistent in the design and deployment of any new AI products and services out there, and that whatever they've done, it's designed to be built and run at scale. And 2025, 2026 is really about your organizations making the right partner decisions, technology decisions to meet all those goals. Now, focusing on process, let's say this is a people conversation. And again, just a little bit hard to see some of this, but strategy is absolutely step one. No more, let's do 5 million proof of concepts. We're absolutely hearing more and more people say, look, yes, we could do finance, we could do HR, we could do marketing, we could do all these different things, but what are the 4 things that will change our actual business outcomes? Move the needle on revenue, move the needle on our profitability, something that we can share to Wall Street. And we see more and more CIOs, CEOs, and this new beast, the Chief AI Officer. How many of you in your organizations have a Chief AI Officer? Anybody out there? Not seeing a lot here. Oh, I see a couple there in the back. A lot of tech companies have them. Not yet a lot of businesses, but that's part of it. But the other key thing here, and what's really not coming out quite as much, is what most people recognize is that governance, that where we need to spend our money here is on governance. The systems that allow us to have greater confidence in the use of our data, where it is, how it's being used, and it's all the models, all the different things that are playing out there. Now, the total spending by enterprises, because we do look at the budgets here. If you look at their total AI budget, how much went into governance, strategy planning, so a lot of services products here and some software, and then of course people, which is training. And that's not really showing here at the bottom, but that's the last bit. In total, this is around 11%. I'd say one of the biggest problems that we think the whole industry has when it comes to AI is that the people number is less than 1%. So we clearly are not investing in training our employees to take advantage of AI as an industry as a whole, both business people and IT people. We need to do more of that. More insights, more value is a critical next step. Now, the next part of this is let's have consistent design and orchestration of our systems. And again, a little bit of a challenge here on seeing the pieces, but applications, absolutely much more consistency in how you think about selecting applications and where you're using them, making that decision about, look, if it's strategic to my business, I want to build it. If it's not, then yes, we should be looking at a SaaS partner, but one who thinks about those things around design and data consistency and so forth. But it's more and more, it's coming down to what's the platform at the infrastructure level, at the model management, application development management level that people have to focus on to really succeed and thrive in this space. And then finally, the data. And as a matter of fact, what we're seeing when we talk to people is their biggest focus right now is on the data. How do I get full advantage out of the data? Now, one thing I'm going to acknowledge, and what we talk, all of you in this room will understand this. The IT organization has been part of the data conversation since I started in this business. However, it's often we're seen as the custodians of data. And so all we say is just make sure that it's there, make sure it's backed up, make sure that it's archived, make sure that we can recover it, but don't worry about the value. That's our problem as a business unit or other pieces. And we've noticed there's this sort of decided lack of thinking about the fact that data is now, for many organizations, a product, and that you have to start adopting product management practices. Good product management practices to allow to do that. One thing that we definitely look to from the IT organization increasingly are to adopt solutions that allow companies to treat their data in that more expansive business way. Things that allow you to have the confidence that you know where your data is and how it's being used, and that business leaders can therefore start making better business decisions about how to exploit it. Now, we combine those three together: applications, AI platforms, data. That's all software for the most part. That's about 69% of your company's likely spending on AI in the coming year. So that's the biggest single piece of where the money is going. But we have this last part, which is build for scale. And this is where it's really hard to show this because it's whited out. The real question here, as we all know, is infrastructure. It's like, how much infrastructure do I need to buy? How many of you actually know your company owns some GPUs sitting somewhere? So I'm seeing a few, all right, not a lot, but they're there. We find them, we see companies who've done that. They bought something off a truck, an H100 somewhere, we think, and they're doing interesting things. But it certainly makes it hard to scale when you do that. And then we have all the major cloud providers announcing $10 billion, $100 billion, $500 billion investment plans for data centers and construction and everything over the coming years. What we tell you, for you, sitting in this room, you're not in the data center business when it comes to building out AI, but you are in the business of making sure that you have a common, consistent platform for managing the running of code and apps in the cloud, in dedicated systems that you may be putting in yourself in your data center, but increasingly also systems that you're going to put out at the edges of your business. Because that's where AI really pays off. It's when you start giving answers in the right place, in the right time, and in the right context. And that's about local. Now, that's 20% of today of what people spend on infrastructure. And it's the software, the as a service, and the hardware all combined. So it's also an important part of this. So you get the total math here, where it plays out, understanding the mix. What we tell people for this particular part of the story, the build and the optimize, it is where partners and making strategic decisions about partners is the most critical. And while it would be great to say, hey, we're in this for, let's do 5-year relationships and 3-year relationships, which is what all of the major IT providers would like you to do. When we talk to CIOs and leaders and we say, let's keep it at 2 years. It's important that you think about these technologies are changing very quickly, especially when you get into the high levels of the models and the advanced services, whatever. It's like, let's keep it 2 levels. But when you're thinking about the underlying systems you're going to use to manage, orchestrate all the infrastructure out there and orchestrate the use of all those data, so the management tools, this is where actually a longer-term strategic relationship is critical to success, because that's going to give you the confidence that you have strong data and the ability to deploy assets and code wherever they reside. Now I'm going to close with one last thing, because we can't do any speech at IDC without talking about what's next and where are things going. And if you could see all these, one thing you would notice is that in every one of these, we talked a little about this idea of agents. So, all right, Gen AI was the topic of 2 years ago. We're now talking about agents, agentic AI. What does that mean? Well, I'm not going to spend, I don't have an hour and a half to tell you what all that means, so I won't do that. But what I will say out is let's give you a little early view on how your colleagues, IT leaders, are thinking about this agent to Gen AI dynamic and how that compares. Because 2 years ago, Gen AI was everything, and it dominated every conversation. And like we said, we saw all these proof of concepts and other things. So, all right, about the same point 2 years ago when everybody was at that same level of maturity on Gen AI, where we are now with agentic in late December, all right, about 46% of companies said, yes, somewhere in our organization, we've got maybe a marketing team or a few teams that are using something that they would call an agent. Now, we're not forcing them to define that, but they think that's what it is. And we're experimenting with it. And that's about where people were with Gen AI at the same point. So that's not a lot of change there. Now, how many people think that this whole new technology is going to be disruptive to their business in the next 18 months? And it was 32%. That sounds really good, but when we asked this for Gen AI, it was 68%. So clearly, at least IT leaders are a little bit more skeptical about, wow, we're hearing all this stuff, but is it really going to have impact on our business? Should we be really worrying about it yet? A little bit more cautious. What we did see that they also learned is that half of them think, yes, this agentic stuff is going to really increase our software costs. Now, with Gen AI, only about 20% of the people thought that at the early stages. Boy, did we all learn a lesson there. But this one, there's definitely more focus and understanding that these new technologies are going to make the ideas of observability and management of that agent fleet a much bigger issue that we have to address and deal with. Now, why is this all important as well? Is with Gen AI, everybody thought that employees were a big part of the story. They wanted to use it, whatever. With agents, we're hearing early messages. Many business leaders, IT employees across the board think, wow, this is threatening my job. So being very prescriptive and descriptive about why agents are valuable to the company and why they're valuable to employees is going to be an important ask. I'm going to close with one last thing here. Let's just put this in one context. There's lots about agents there, but from our perspective, probably the group that is most going to be affected by agents are the developers and data scientists that you're all supporting. Because when you think about what an agent is, what you're saying is I'm taking a product, a digital service and a product, and I'm essentially automating many of the things that a product management, product development, SRE team is doing to keep that digital product up and running and getting better all the time. I'm doing all those things like taking actions and insights, and more agentic AI is about I'm using Gen AI technologies and large language models to automate many parts of that process. And so this is why the thing to pay attention to isn't right now for most of the kinds of AI agents, but it's the introduction of agentic workflows into the application development process. That's what's probably going to be the most significant thing that you're going to want to pay attention to in the next couple of years, tracking that and understanding where to use it. So let me close by telling you, right, we started on an AI journey, but now we're clearly finishing on an agentic AI journey. Your goal to succeed, what will help you be the leaders in making this happen? First of all, focus, helping your company navigate the agentization of every application that you currently use and support, how to understand the timing, the values, the impacts on data. Also helping develop the orchestration and the consistency system so that I'm not just developing new agents, but I'm managing a growing fleet of agents that are out there around the world affecting my business. And last, recklessly understanding our job has always been and will always be to help companies scale. They have the confidence that the underlying infrastructure that they're using, whether it's in a corporate data center, whether it's in the cloud, increasingly whether it's in an edge location, is well managed, consistent, and you have the ability to understand how effectively it's being run from a cost, availability, and security perspective. So with that, I hope you all have a great rest of the show and hear more about how SUSE is going to make your AI life more effective. Thank you.
If you're anything like me, you're probably still running on the fumes of excitement from the last couple of days. And why not? We've had some incredible keynotes, amazing announcements. We've had some cutting-edge technology on display. We had the SUSE band play last evening. That was awesome. But yeah, I was waiting. Thank you. When I was asked to give this keynote, I was genuinely thrilled. And then I started thinking, all right, what can I do to grab some attention quickly? How can I make this opening somewhat funny, somewhat witty? I thought, okay, that should be easy. Let me just fire up my AI assistant, do some smart prompting, and I'll knock it out of the park. Spoiler alert, it wasn't easy. I've stared at a blank page for longer than I care to admit. I've prompted different language models, wrestled with joke structures, chatted with a lot of assistants. And let me tell you this, I genuinely believe that AI is incredible in doing a lot of things. But it's definitely not turning me into a comedic genius. Nope, not happening. Okay, that landed better than I thought. So, good. But here's the thing. What I can do is I can share an insightful and hopefully engaging look at the future of SUSE AI. So bear with me on the humor front, and let's delve into the brilliance of what SUSE has to offer in the world of AI, shall we? Now, yesterday, Pete Smales shared with you how SUSE can help you at every step of the way on your cloud-native journey. With SUSE Rancher Prime, you have a platform to manage all of your cloud-native workloads. And now that you have embarked on that journey, how do you ensure that you are moving fast, that you are the best in class in your industry? How do you ensure that your customers are getting those amazing experiences that they deserve? How do you ensure that you are winning? And there is nothing more transformational than AI in today's day and age to help you win. And we at SUSE truly believe that the true power of AI can only be unlocked with a robust, flexible, and secure platform. Our vision is clear: to be the platform of choice for your AI applications. We are talking about empowering you to build, deploy, manage all of your cloud-native workloads seamlessly, efficiently, securely, regardless of where they are running, in the cloud, in the data center, even in air-gapped environments. We are committed to providing you the foundation that fuels your AI innovation. But as we stand on the cusp of this new era, we as an industry are faced with a critical dilemma. We need AI solutions that are not only powerful, but also enterprise-grade and trustworthy. Because as you embark on this journey of transformation with AI, you will be confronted with a plethora of challenges. And Rick just talked about a lot of those. When you move from POC environments to production environments, what are the investment priorities that you need to think about for 2025? And this is where SUSE comes into the picture. As your trusted partner, to help you navigate some of those challenges. And I'm here to show you how. So let's begin. Now, the world of AI is rapidly evolving. New tools, technologies, frameworks, they're coming out every other day. I mean, what is relevant today may not be so relevant 6 months from now. In this scenario, your teams are grappling with this gamut of tools and technologies that are constantly changing, constantly updating. So how do you ensure that they have the choice to select the most innovative projects that power your innovation, while at the same time, you get the assurance that these projects are ready for enterprise-grade consumption at scale? And this is where SUSE AI's libraries, curated components come into play. I'm excited to share that we are expanding the SUSE AI library so that you get a library of curated, validated open source projects, trusted components built via SUSE's secure supply chain. Think of stuff like Open Web UI pipelines to power your agentic AI workflows, or an ML flow to power your entire ML lifecycle. SUSE is investing in curating and validating these technologies so that you can fast-track your innovation efforts. And we're not stopping there. We're also providing you the blueprints to implement these technologies, step-by-step implementation guides, so that you can fast-track your time to value with your investments. But you need more from SUSE, don't you? All of our organizations, they're faced with, we have these complex, multi-step business processes that involve human-level intervention and reasoning from time to time. Just think about it. Think of those processes in your organization, those intricate sequence of actions, step by step, that involve data analysis at some point, decision-making at another point, your human reasoning at some other point. Such processes are ripe with inefficiencies. They hinder your organization's ability to move fast. And this is where AI agents come into play. Remember what Rick was talking about 10 minutes ago? Think of a scenario, let's say in healthcare, where an AI agent you're talking to, an application, can help you diagnose an illness. It can ask you intelligent follow-up questions depending on what your responses are. Based on your responses, it can understand and identify the possible conditions. And based on the same, it can help you book a doctor's appointment on your behalf, basically fast-tracking your availability and your ability to get a specialist appointment in a fast manner. That's just one example. Such workflows where multiple AI agents get connected together to solve complex business problems unlock an unprecedented level of operational efficiency and automation for your organization. And today, I am thrilled to announce that SUSE now enables the secure implementation of agentic AI workflows. Not only will we provide you the tools to build these workflows, but again, we'll provide you the blueprints to implement that in your environments. Again, fast-tracking your time to value and your time to innovation. Interested? Eager to learn more? Scan this QR code and let us show you how. We are introducing a blueprint for Langflow to jumpstart your journey. And because we believe choice is key, we're also offering you Open Web UI pipelines as part of our library, another powerful option to build these complex workflows. But you need more from SUSE, don't you? We at SUSE also recognize that the privacy and security of your enterprise data is of paramount importance to you. And as you scale these GenAI implementations, you're also concerned about the accuracy of the output that you get from these applications. Think of a scenario where you have implemented an AI assistant in your company. How do you ensure that the answers that that assistant is giving you, they're not biased? How do you ensure that they're not violating your company's brand guidelines or any of the corporate policies that you have in place? That is a scenario where guardrails comes into place. Guardrails as a technology is basically what the name suggests. It prevents any unintended behavior on part of these applications. They're like an autopilot system, helping your planes stay on course. And that's another area that SUSE is doubling down on with SUSE AI. Just to be clear, we're not implementing autopilot systems, but we are committed to ensure that you get AI you can trust. And to that end, I'm again excited to announce a couple of things. One, we are enabling you to build guardrails technology in your environments by providing you the right blueprints to do so with SUSE AI, ensuring you have controlled LLM interaction in your organization. And number two, we are announcing a partnership with Infosys to integrate Infosys responsible AI guardrails with SUSE AI. With this partnership, not only do our customers get access to the guardrails framework, but our joint customers also get access to Infosys industry AI models, Gen AI applications, agentic AI workflows specific to your specific business needs. So there's a lot in store. Yeah. Now, going back to what Rick was talking about a while ago regarding costs. As you're doing all of this, your costs add on. They pile up. Especially as you're moving from small-scale POC environments to large production deployments. These costs start becoming prohibitive. So you as an organization, you must ensure that your applications, your language models, they are performing at their peak. That your compute, your hardware, it's fully utilized. You must ensure that your investments are fully leveraged. But before you do any of that, what is even more important is that you have visibility into the health and status of your AI infrastructure. Because here's the thing, you cannot fix what you cannot see. And to that end, I'm delighted to announce the launch of SUSE Observability for AI. We offer you real-time visibility into token usage, into LLM performance, drift, latency, into the utilization of your expensive GPUs, into the response time of your applications. Your teams gain insights into which apps and users are driving your costs. And not just that, you can visualize your entire application landscape and understand the interdependencies between the apps and the language models and how they're interacting and how that's impacting your business. And that is the visibility and control we are offering you with SUSE AI. So let's recap this a bit. SUSE AI is helping you deliver groundbreaking innovation at scale. The AI landscape is rapidly evolving. You have to keep up with the pace of innovation in a safe and trusted manner. We offer you the SUSE AI library with the curated components to do that. Then we take that one step further and offer you specific blueprints to implement those components in your environments, fast-tracking your time to value. To add to that, we empower your teams to focus on high-value activities by automating the repetitive tasks with agentic AI. Then we lock down that entire environment with SUSE AI security, ensuring that you have complete trust that your private, confidential enterprise data stays within your control. In addition to that, we also provide you the guardrails to ensure that you're doing all of this in a safe, trusted, and responsible manner. And while you're doing all of that, with SUSE AI Observability, you have complete control and visibility into your AI environment, so you can maximize your performance and resource utilization. And you put all of that together, and you have a complete platform to deploy and run your GenAI applications, and that is what SUSE AI brings to the table. Isn't that amazing? I sure think it is. I sure think it is. Now, on day one, Nicole said something that really stuck with me, that resonates with me at a personal level. She said, nothing of significance is ever accomplished alone. And we at SUSE, we fully recognize that organizations need a trusted partner at every step of the way on their AI journey. And this is such a diverse, fast-moving market landscape. The reality is that no one technology provider can address all your challenges. We at SUSE, we are fully committed to tap into the power of our global partner ecosystem to help you address these challenges. And to that end, I'm delighted to announce that we are launching a complete enterprise AI infrastructure solution with our long-standing partners, Infosys and HPE. And this solution will bring together SUSE AI with best-in-class system integration capabilities from Infosys and hardware from HPE. The combined power of these services will offer our mutual customers everything they need to build, deploy, and scale AI application for their specific business needs. And it's not just me saying that. To share in the excitement, please welcome on stage our friends from Infosys and HPE. Ram, let's start with you. At Infosys, you have seen multiple AI applications and implementations across different industries. So could you please share with our audience some of the challenges you are seeing in these environments?
So the challenges are put three things. One, business, technology, and the human element. So when it comes to business, the AI initiatives need to be aligned with the business needs and objectives to achieve a certain business outcomes. Based on that, the relevant use cases on AI projects need to be defined. Now, when these AI projects are defined, it needs to be supplemented by an appropriate end-to-end secure core infrastructure stack and the relevant AI models, applications, and workflows. And the last thing is the human element. Look, AI can deliver huge efficiencies, but can be even better when augmented with the human in the loop. For example, we have developed a learning management platform where we are using an AI model based on reinforced learning, wherein the AI generates content, but we have subject matter experts which review that, enhance that model, customize to the target audience so that it is accurate, and then whatever we update, the AI model learns continuously, and then it becomes smarter and smarter. You never know, it can become smarter than us over time.
Never know, right? No, that's very interesting. So in this context then, how do you see this partnership between SUSE, HPE, and Infosys helping our customers?
Yes. So as you rightly mentioned earlier, there are proliferation of AI technologies coming, everything, a lot of new things every day. So what the partner ecosystem is doing is to simplify the technology stack, okay? Simplify the technology so that engage the customers to focus on what they do best. The business knows their business best. So we let them focus on those areas while as the partners, we focus on the stack. That's the business complexity. Then do the staged implementation through a crawl, walk, run approach, wherein do multiple proof of concepts, variety of technologies that can be used for that customer and industry. Then identify a few targeted pilots and see what works within that system. Then harden it with the right infrastructure stack, which is safe and secure, and then scale big. So that is on the technology complexity. Then comes the scaled investment. The AI can be very expensive, as we heard from Rick as well. So what we are doing very innovatively is, along with SUSE AI Stack and with HPE GreenLake, what we are doing is coming with concepts called start now, pay later. And then going with pay as you go. And then we go scaling higher based on the progress that we see and whether the AI projects are delivering value, and then we're going. So this phased implementation is definitely helping us.
Thank you. Thank you. I hope that was insightful for our audience, and we can kick off some journeys pretty soon. Thank you. Tom, over to you. So HPE has been a key player in the AI infrastructure space for a while.
We have a wide variety of AI-ready solutions in infrastructure. And in fact, what that does is it actually provides both skill as well as repeatability and security for those solutions, right, and efficiency. And as a result of that, we also made certain that we were dealing with one of the big demands around an AI solution and deployment, which really happens to be dealing with those data-intensive AI environments, right, those applications. And so it actually meets that criteria as well. The example I'd like to use in particular is a newly released product that we have. It's our HPE ProLiant Gen 12 server, which has all of those capabilities and more. But what I'd like to do is highlight one in particular around the security aspect of it, because that's a huge concern, along with the optimization of the data. And on the security side, HPE has some very unique IP that we refer to as integrated lights out technology, which is very, very unique in the marketplace. And it affords you the opportunity to look at everything from the firmware on the chip all the way up through including the cloud. So it provides total security end to end. But in addition to that, and thank you for the plug on the GreenLake side, is we have a very efficient deployment model that we have. It's a solution we refer to as HPE GreenLake, which really provides a cloud-like experience, but it's on-prem. And what that does, it actually also brings efficiency to the environment, whereby you can lower the costs, but more importantly, you can even have better control of the data.
That's incredible. How do you see this partnership helping our joint customers?
Well, I have to say, I'm really excited about this partnership. It's almost as old as I am. No, but it's greater than a 30-year partnership we have with you all. It's just been an amazing run. We can point to many, many solutions where we've co-developed these solutions, gone to market. And by the way, these are integrated, enterprise-grade solutions that we've done together. And that actually help the customers, our joint customers, if you will, mutual customers, keep pace with the ever-changing and evolving trends, both in the industry and the market. But when I think about the relationship more importantly, and particularly from some of the announcements we had this week, it's very exciting to think about leveraging, the open source AI stack that exists with NVIDIA, with SUSE, pardon me. But more importantly, one of the things that I find is that when we combine that with the capabilities within HPE, where we actually have this AI grade kind of technology and solutions, it's pretty exciting that we can provide a total end-to-end solution for our customers, providing efficiency, scalability, security, and it's really not only a benefit for the customers, but also creates differentiation for us jointly in the marketplace.
Absolutely does. I mean, we've been talking a lot about guardrails, and we've been talking to a lot of customers, and guardrails seems to be gaining a lot of traction. So how do you see Infosys guardrails working with SUSE AI for our joint customers?
When we looked at the market, we found that there is a lack of scalable open source solutions, right? Especially for AI safety. So this led to kind of development of our Infosys responsible AI guardrails to serve our in-house programs. Now, we went ahead and open sourced it very recently, right? Now, this responsible AI guardrails adds to the curated set of solutions of SUSE AI and actually increases the safety profile of SUSE, right? Especially it addresses the OS top 10 LLM vulnerabilities that are out there, right? Now, this guardrail sits within the AI tool section of SUSE AI and helps you, provides you the codified compliance, safety, security aspects, and also explainability, moderation, and a lot more, right? Now, along with SUSE AI's observability and the responsible AI guardrails, now for SUSE customers, you will have an enterprise-grade platform, which provides you an opportunity to develop trustworthy, safe, and ethical AI solutions, thus making SUSE AI the platform for enterprise AI applications. So, in fact, I request everybody in the audience to please go ahead and contribute more to open source, and I also look forward to achieving more with SUSE AI.
Perfect. Thank you. Thank you. Thank you, gentlemen. We truly value this partnership. These were great insights. Can't wait to share this awesomeness with our joint customers. Thank you for your time. So hopefully, we've not given you too much jargon today. We've given you the right tools and the insights to drive your AI implementation. Here is what I'll leave you with. 8 months ago, we announced our vision with SUSE AI. 4 months ago, we delivered on our promise and launched that solution. And we've been consistently listening to you to understand the challenges you are facing in your AI environments to help you innovate in a safe, ethical, and responsible manner. And we're not doing this alone. We are leveraging the power of our ecosystem to deliver end-to-end solutions that meet your specific business needs. Because let's be clear, the future demands AI innovation. And with SUSE AI, you're not just prepared for it, you are leading the charge. So go forth, be pioneers, be creators, and let's build an AI-powered future that's both safe and trustworthy. We are ready. Are you?
Welcome. It's been a good year. Welcome back to Demopalooza. This is the Demopalooza 2025. It isn't the 25th Demopalooza, but it feels like it sometimes. We've gone numerous places with Demopalooza, and this year, why not go to the far edge since we talk about it a lot? We're in space. So Aaron?
I'm actually going to give you that.
Thanks, man. I think this will help. So we're going to go to a few slides. I wanted to talk to you a little bit about the core tenets of SUSE and core tenets of what we're doing in the space station, the International SUSE Station. All right, let's see if this works. So big part of our core tenets for deploying things at the edge is freedom of choice. So that could mean things with the partners that we have, all of the equipment and the experiments that come up to the SUSE space station. Freedom of choice, it includes operating systems. It includes a wide variety of different hardware platforms, different architectures, different things that we want to deploy on applications, virtual machines, containers. All of these things are all part of that freedom of choice. And it's important when we're partnering with people. We never know what they're going to bring, but we want to be able to manage it all. So freedom of choice, the big first one. Next is security, of course. From the ground up, all of our things need to be very, very secure. Think about it. If we wanted to patch things, we're going to need to actually manage a wide variety, like we said. There's also things in security that, it's tough to get some service and patches sometimes, but security is a big tenet that we need to care about because, even getting DoorDash up here is really expensive. Another piece and part of that is optimizing the hardware, right? Again, it's very expensive to come up here, so we're going to have to actually use all of this hardware very, very efficiently. So we want to be able to see what's happening with all the applications that we're using and all the technology we're putting together. So optimizing hardware and its usage, very important. Also, optimization of bandwidth, right? Again, we're way up here in space. Communications are very, very expensive. This is not just your phone call to mom. This is mission critical stuff, literally mission critical. So bandwidth optimization, caching things, being able to reuse the packages that we transfer, the images we transfer. So we care a lot about that. Again, that's the core tenets of everything that we do in the International SUSE Station. Aaron, why don't you talk to us a little bit?
Let's talk about what we've actually got running. Because one of the key things that we're trying to do is, much like businesses are trying to just get businesses done, we're trying to just get science done. We don't care about computers. We don't care about operating systems. The last thing we want to say is, you can't do that piece of science because we don't support that operating system or that language you want to develop in, right? We just care about science. That's all we want to do. So here's what we've put on each of our space stations to really open that up to let people develop anything they want. So the first thing is how we're going to treat hardware, right? We've got hardware that's been donated from all different vendors around the world, all different types of processors, right? x86, ARM. What we really want to do is separate hardware from the science that we need to do, right? Hardware comes and goes. You get new hardware, hardware dies, it's replaced. We want to separate those two. So what we're going to do is we're going to take all the hardware in our environment, and we're just going to treat it as a cluster and say, this is the amount of hardware we currently have, this is the amount of work we've got to do, and let the system figure it out. So let's dive down and get nerdy and really see what's running on these machines. So the first thing we need to worry about is we need to worry about storage. We need to store files. Now, we've done this for years with Longhorn. Anytime Longhorn, when you go store a file, it immediately stores at a minimum of 3 other servers, right? Like I said, we've been doing this for years. This year, we've announced and we're making big changes. The first thing, we've modified Longhorn 2. It's in pre-release right now. We'll be shipping very soon. 3 times the performance that we're getting. It's really 1 to 10, depending on what you're doing, but massive speed increases. Now, this is great, but like I said, we've got hardware from people all over the world, and much like our customers, you probably already have some storage on site, some very, very good storage. And what we are now doing is we're supporting a bunch of those existing storage vendors that are already there, and what we're allowing you to do is actually swap out that core storage with whatever storage vendor you want, or an approved certified storage vendor, of course. But now you have the choice and the option to really leverage the storage you've already got. So that's good. We talked about storage. Let's talk about actually running containers, right? So of course, we can natively run containers on this, but I want to take a minute to remind you not all containers are equal. Jeff mentioned security is a big issue, security and reliability. In order to do that, what we want to do is we want to minimize the amount of CVEs or known bugs that we allow on our space stations. So we're going to start with when we actually start to develop the apps, we're going to make sure we're starting on a secure platform. The problem is right now, if I go and I just pull Python latest, Jeff and I checked this last night, there's 112 critical and major CVEs in the upstream version of Python 3.12. Now, what's funny is that's just the top ones. There's, oh my God, 800 if you include middle and low tier, right? So we're talking hundreds and hundreds of CVEs. If you compare that to what SUSE has done and rebuilt Python on a SUSE-based operating system, there's a single CVE. Single known bug. It was found last week. I'm sure that whoever's writing the upstream code will have it fixed in a couple days, right? But that's the key is we're making sure all of those known CVEs are automatically applied to your base container images. And we're not just doing that for Python, right? We're doing that for whatever development languages you want. These are the core ones that we support that we're doing the exact same thing. We're rebuilding on solid SUSE operating systems so you get very few CVEs. Okay, now let's talk about virtual machines. So now we need the ability to not just run clusters and containers, we want virtual machines, and we want virtual machines from all different operating systems, right? We need to support a variety of different versions of Linux as well as Windows. So what we really wind up with is the ability to just take all of our hardware, pull it together, and then run whatever workloads you need to do science. It doesn't matter what the operating system is, what the container is, or what that virtual machine is. But with all of this freedom of giving your developers choice, it brings up some more issues, doesn't it? I now all of a sudden have a ton of different operating systems in my environment that I've got to manage. Jeff, what can I do with that?
Well, SUSE Manager, or formerly known as SUSE Manager, I like to say the artist formerly known as because, Minneapolis Prince, long story. Multi-Linux Manager is here to save us from all of the pain and suffering of managing a whole bunch of different operating systems, right? So instead of worrying about what we support, how about we are able to patch and update whatever is brought to us by our partners in the International SUSE Station. Not only that, Multi-Linux Manager, great, patch everything, fix everything, keep it secure, and again, back to our tenant, bandwidth is important. One of the key features of Multi-Linux Manager is the ability to cache packages where they are needed most. And once it's on that side of your firewall or space, you can cache that and be very efficient in those communications. And package one time goes across the bandwidth and then is absolutely being able to deliver it to other machines. So again, coming in, being able to cache it locally, very, very good for what we want to do in the space station. But wait, there's more. So what about if something breaks? The nice thing on the other side of the coin is SUSE Linux Manager support, or SUSE Multi-Linux support. I'll get it here soon enough. But it's that single phone call for all of these operating systems and being able to get help when you need it. So a single phone call for all of this.
Yep.
I think there's another thing that we want to talk about is a recent announcement with the SUSE registry, right? So we have a private registry now talking about packages and updates and configuration management. That's one thing. Going into the container world or cloud native, we also have the need to cache and pull things through. With SUSE's private registry, we're also bandwidth friendly. We can update and store our images and containers and artifacts in a registry and also be able to cache those with a pull-through cache and secure all of it. So this is another thing that we want to talk about. We should have them stop by the booth and ask about the private registry. Now that we've got all that, the ability actually to deploy in a uniform way, getting really efficient, being able to define your deployments as code. We can leverage Fleet to not only roll out the artifacts, the containers, the security pieces, but also by defining a type, we can now repeatedly install this on any of the space stations that we have around. So define a type, push it out. Fleet will take care of taking that registry component as well and being able to deploy that to all of our space stations. So very easy to get a handle on virtual machines, containers, all of these workloads.
Perfect. So that's what we have today on all of our different space stations. We've got a nice base that we can support all these type of workloads. However, we're in the process of rolling out a brand new capability to all those space stations, which is really observability. So if we can have the slides back up for a second. Awesome. So what I want to do is I just want to set a base level before we kind of show you how observability works. I want to dig into it and kind of get nerdy and explain exactly what's happening. So observability is really about monitoring and measuring health and performance, which is great, right? That's what everybody says that it's about. But let's talk about how that actually happens. How do we get those details? How do we figure out what's in a service? So the first thing is we've got a cluster, right? We've got a bunch of nodes, and on those nodes, we've got a Kubernetes cluster, and then we're going to have workloads, right? We're going to have pods that are running, and we're going to have services that connect those pods to the outside world. So how are we going to get all this cool observation information? The first thing we want to do is we want to get information from the node. So we're going to install a node agent. And this node agent is going to do a couple things. First, it's going to look at processor and memory usage, and then we throw in an eBPF driver. And that lets us do something very cool. Not only do we see network traffic, we actually get the ability to time network traffic. So we not only understand what the communication is, we know on average how long that communication normally takes. So that means we can immediately see when things speed up or slow down. On top of that, we also get the ability to see every single process that's running on that node. So we really get full visibility on what's happening on that node. Now, since we're doing this in Kubernetes, we're going to start to really leverage Kubernetes. So we are going to tell it to, whenever it sees a change, write this to a log. And notice how my log has a time going across it? That becomes very important in just a minute. So we're logging everything based on time. And now what we're going to do is we're going to tell Kubernetes that we're going to define a daemon. So we're going to say, on every single node in our environment, and any node we ever define, put those agents, so I now have full tracking. Now we're going to do the same thing for Kubernetes. We're going to install a cluster agent that's going to give us deep visibility into that cluster. So now I can see every one of these pods, and I can see exactly what's going on with that pod. And not only can I see that, I can also see everything that's going on with the service, right? So I know the communication that's going on. And it's not just for existing pods and existing services. Every new thing that comes into Kubernetes is automatically going to have observability turned on. Now, let's dive in and see what we're actually seeing on the Kubernetes level. So here, I'm creating a pod. We can see the pod get created. We can see it goes ahead and creates a container inside that pod. It goes to grab the image, and it crashes. And it doesn't pull because Aaron screwed something up, right? I got a crash back-off loop. My image name isn't right. So what do? I go in, and I edit it. And the system notes, Aaron made a change to that deployment. Now, all of a sudden, the image is able to pull, it pulls, it spins up the database, it scales, it runs down, right? So now we have a full log of what's going on, but notice something else. Remember a couple slides ago we saw that processor usage spike? Now we have context. Now we know why on that node that processor came up, because Aaron spun up a new pod. So we're starting to get real nice context across our entire system. Okay, next thing we're going to do is logs, right? We're going to automatically inject and grab logs, not just from Kubernetes and not just Kubernetes-based container logs. We're going to get the logs natively out of your application, so we're going to be able to view all those. And of course, just like everything else, it's dropped on the timeline as soon as it happens. So again, full correlation in time. So this is great. We just have a ton of information, right? We've got information coming from those nodes. We've got information coming from the containers. We've got logs. We just have a ton of information, right? And what happens, this is great, but real quickly I become overwhelmed, right? How do I use this to really find out if my systems are healthy? And that's really, to me, this is one of the things that I absolutely love about SUSE observability is the topology view. Now, I've been doing computers forever, right? And I've done a bunch of service management stuff. And all the service management stuff that I've done before is you define what the service is, and then you can manage it. But you have to manually go, well, this is part of the service, and this is part of the service. What we do with SUSE observability is we leverage all those Node and Kubernetes agents we've got running to let it automatically detect what's happening. So we see a request come in through a specific service. It sees the communication happening between the pods without you telling it. It automatically realizes this service contains all these different parts and components. It then lets me really just focus and throw away all the irrelevant information. Let me just see what's relevant to that service. Now, just by doing that, is this service running? Yeah, it's green. Things are cool, right? What happens when something goes wrong? It turns red. We can see here a container just crashed. We can see there's no longer network communication going to our downstream pods. Again, the entire thing didn't turn red, just the components that aren't working. How quickly can you pinpoint approximately where your problem is? Very quickly, because I can see what's affected and what's affected downstream. Now, what's great is we've got all that information that we stored before. But again, observability lets me put a focus on and just see the stuff that's relevant to this. And this is very close to the graph that I actually see. I see things were working great, and then they broke, and the timeline literally turns red. And it's like, oh my gosh, things are not working after that. Where do you guys think the problem was? Probably right before the stuff where everything broke. And this is what's great, is we can click in on that, we can drill down, and we can actually see somebody went in, made a change to the deployment, and changed the entropy from 1 to 2, and that's what broke everything. So very easy to give you full visibility on what's going on. I got to breathe. So with that, let's actually see it, right? I want to pull my friend Yaron out, and Yaron, let's see what observability actually looks like.
Thank you, Aaron. It's great to be here. So let's talk about SUSE observability. Aaron, you did a great job explaining that. If you could take the helm and actually navigate us through while I talk, that would be great. Welcome to SUSE observability, where when we enter, we see an overview of all of our services. And now I've already filtered this down into a specific cluster and namespace. What we can see is health and performance of all of these services. But where SUSE observability, of course, really shines, as Aaron explained, is our topology view. So Aaron, if you would move there, please. When we look at this, we see the world in a connected state. We see all of these services, they're communicating with each other. And what's great is that we're in a green state currently. Amazing. However, if we look at our newly released unified timeline at the bottom, we see that though we're in green now, we used to be in a deviating situation. And this is great, because previously, with SUSE observability, our timeline was only for a specific resource. Now, whichever slice you make, you can see its health. So let's go right to the start of where we saw this outage. And wait, we see our front end was down, actually, or at least deviating, meaning our customers were either experiencing latency, experiencing errors. What we also see is that the downstream service was also in a deviating state. So let's investigate that. We open its component view, and immediately we see all of the correlated data. We see its Kubernetes metadata, related resources. We see the monitors, which monitor health and performance over time. We see the correlated events, and if we scroll down, we will see the metrics. We see network throughput in this case, bytes sent, bytes received, all of this correlated over time. So let's go back up, and we actually want to see what was going wrong. So we annotate the time where actually this outage started. And what we see is when we annotate that is there was a deployment which just previously happened. So we'll go and investigate that. We open up the deployments, and what we see is we see 2 configuration change events, one at the start, one at the end. So we want to open up its change set. And we scroll down, and what we see is, okay, we deployed a new version, but the version that was deployed was not of this service. It was actually of a different service again, because we know how everything is connected, how everything is related. We're able to see those changes correlated across time, across resources. Whoa! Jeff, man, what's going on here? What did I do wrong?
Nothing to worry about. This happens every day on the International SUSE station. We just got an alert from Mission Control, and they're asking us to deploy an application.
Okay, well,
So this
let's hear it. What do we need to do?
Sure. So if we can go to the deck, I'm going to describe a little bit. All right, so the application command that we got is we're going to deploy something for our SAP team. They've got a edge integration cell that they want us to deploy, and it has also some components that it's going to talk to. We're also going to talk to a large language model, so we'll need some middleware to actually run that. Luckily, we have that in SUSE AI, as Abhinav just talked about. The other part is a custom application that we're developing that's going to integrate with some APIs. So before we get started too much, I want to talk a little bit about the dependencies, Jeroen, in the SAP Edge integration cell.
Yeah, let's hear it, Jeff.
So along with the SAP Edge integration cell, you're going to have to deploy 4 different components. One of them is Redis, the other one is Postgres, and then there will be the Cert Manager for managing SSL certificates, and MetalLB. All these components are the dependencies of the Edge integration
Yeah, but
cell.
Jeff, wait a minute, man. I've played around with this in our lab. If I pull all of these from upstream, and I don't know about you, but I thought we were talking about secure and trusted.
Yeah.
Right? Aaron, can you pull up SUSE Security, please? Yeah. Let's go into our security risks and then vulnerabilities report, because I've installed this. We're looking at our lab environment. We want to filter down into each of these namespaces, so Redis, Cert Manager, MetalLB, and Postgres. And we'll wait until Aaron has typed all of that, because that's quite a number of typing. Let's apply that. These dependencies actually contain 64 vulnerabilities, and if we sort them actually, we can see that these are not like small vulnerabilities. There's actually a ton of them, pretty critical. So our CISO would kill us if we would do this. Is there a better way, Jeff?
Well, I think there is, actually.
There definitely is a better way, but before we even get there, let's just meet the requirements properly, right? Let's build a cluster, let's put the proper requirements from app collection in and just get it going.
Yeah,
right?
That sounds like a great idea. Who do we need for that?
I think we're going to actually deploy another cluster.
Should we maybe get Alejandro out here to do that, though?
I'd love that.
Okay.
Let's bring our SRE, Alejandro Bonilla.
Everyone.
So what we're going to have Alejandro do is we need a downstream cluster for us to run SAP Edge integration cell, and luckily they just require a Rancher downstream cluster. So let's have Alejandro go ahead and create that for us.
All right, perfect. So we're going to go ahead and click Create, then go into SUSE Virtualization, Harvester here, and Rancher Prime for now. Then click on our host cluster. Then we're going to provide a name for the Edge integration cell, and then just set the virtual machine resources, including a pool name. We want 3 nodes in that cluster. We'll set the CPU, RAM, and the namespace. Of course, we're going to choose /15 as our image, and then VLAN 1 for our network configuration. We're going to scroll up into the Show Advanced section so that we can then use a Cloud Config template that has all the requirements for a virtual machine, which is going to do a package installation, just inject some commands, and then create my user. And then we're going to scroll down to the Kubernetes version that is tested for Edge integration cell 128. And then we're going to choose the Harvester cloud provider. With the Harvester cloud provider, it gives us the load balancing service, the CSI pass-through for persistent volumes, and a topology awareness, so that our hosts are completely aware pretty much for HA purposes. And then we're going to add a label for this cluster called App Edge Integration Cell, so that our fleet bundle will then deploy on this cluster. We'll go ahead and click Create. All right.
Awesome, cool. So that's created. One of the things that I want to point out is when he went to that Harvester provisioner and he mentioned that the load balancer is automatically provisioned, Jeff said there was a requirement for Metal LB. Does that mean we no longer need Metal LB?
No, you no longer need it, because the cloud provider interface provides all these features that are just make SUSE virtualization cloud native, and it just provides everything you need for your virtual cluster.
Right, all downstream clusters automatically. IP addresses, they get storage without absolutely anything.
You're correct.
So why don't we go in and see if that's actually cleaner? Let's take a look. It's probably had a chance to deploy. Let's take a look at Fleet and see what those apps look like.
Yeah, let's do that. Because this sounds great, right? He applied the label, so clusters up. Let's go to Fleet. So when we look at Fleet, we see our edge integration shell, and it's actually green. Let's click in it. And we see Cert Manager, Postgres, and Redis have been deployed. As Aaron said, we don't need Metal LB because SUSE virtualization provides it. So let's go into SUSE Security, because these apps are actually now deployed. So go into the edge integration cell, we choose the SUSE Security menu item, and then click on the box, which will take us into SUSE Security. And of course, we go to our vulnerabilities report. And what we want to do is we, again, want to filter it down. Let's choose all the namespaces just to be secure. So Metal LB, Postgres, Redis, and Cert Manager. Yes, click Apply, please. Man, there's one vulnerability. So we went down from 64 to 1 vulnerability just by using application collection instead of upstream. This is great. This is what we can sell. Our CISO will be happy. And that one vulnerability, that was only 2 weeks old, so I'm sure that in a week's time, we'll actually be down to 0 vulnerabilities again, and we'll be running our edge integration cell in a very secure way. We deployed this on SUSE virtualization. And as Aaron said, can we
observe?
Yeah,
let me drive.
Right? That's what you brought me out for. And of course, the answer is?
Yes.
Audience? Yes, we can. So let's bring up virtualization, observability. Go into the hamburger menu, and let's have a look at what SUSE virtualization actually shows in SUSE observability. We scroll down, we go into SUSE virtualization, and what we see is we have multiple different options to choose from: virtual machines, launchers, controllers, and hosts. So we want to take a look at the virtual machines, because that's what we created. And what we see is we're actually observing a ton of virtual machines at the moment. We're observing a CentOS machine, Liberty, we're observing some Red Hat machines, a SLES machine, and even a Windows server. So that's great, right? But if we can look at topology, we actually see how these are running, where these are running. So we see for each of these virtual machines on which hosts they're actually deployed, so which host systems. And they're all green, which is great. So let's have a look at the SLES machine. We open its component view, and like any other resource that you see in SUSE observability, you see the metadata, you see correlated events, you see metrics like CPU usage, memory usage, and if we scroll even further down, we see things like I/O times, I/O operations, and the traffic on the disks, which are actually much needed performance metrics for a virtual machine. If we scroll up, we actually also see on our timeline that there was an outage. So let's click into that, because something happened to that virtual machine at some point. We see at the center of that outage, there were some changes happening, actually, and we want to see the last change. What happened to this machine? We scroll down. Al, what did you do, man? You saw how busy this machine was. You scaled down the cores? You can't do that. So let's go back into SUSE virtualization to actually try to fix this. And what we've made easy is actually to go from SUSE observability to SUSE virtualization. You just click those three dots, click Manage Your Virtual Machine, and if you click that, we're back into SUSE virtualization. We can actually adjust that change that Al made. Isn't that great?
So I'm a Kubernetes fanatic, like a lot of you guys, and one of the things that I love most about Kubernetes, don't giggle, is namespaces. Right? Namespaces are fantastic. What a namespace allows me to do is have my own little world to do work in. And I can create my own world and delete it as much as I want. So here I've created a namespace for us to do some development in. So I'm going to throw some things in there. I'm going to put a service in there. I'm going to put some pods. I'm going to put security. And I'm going to put some secrets. That's my little world. Now, what's great is I create namespaces throughout the day, and when I'm done with them, or more likely I screw something up, you throw away the namespace, and it disappears. When a namespace is created, the resources that are taken are tiny. The only resources that are taken are the resources for the pods and the services that are actually running. The great thing is when I'm done with that, and I throw it away, and I delete it, it deletes everything in that namespace, and I return those resources, right? So it's very, very resource-friendly. This is why developers love it, because they can create environments, do some work, throw them away, restart. When you combine this with GitOps, this is where things get cool, because now when I create that namespace, I can say, give me a small clone of production. So I have my own environment that looks like production that I can do development in. And in fact, I can pop up another namespace that has the exact same components, but because they're in different namespaces, they're in different separate worlds, right? And I can develop on my own, Jeff can develop on my own, we're completely isolated. But there's a problem. The problem is Kubernetes is very, very flexible. What I mean by that is one of my other favorite things in Kubernetes is the ability to create Kubernetes operators and Kubernetes CRDs, which let me fundamentally change the way Kubernetes works and processes information. I can customize it for my own needs. But when I make that change goes beyond my namespace, right? It's actually affecting all Kubernetes clusters that are in that cluster. So that CRD change that I made affects every other namespace. Wow. That means I no longer have that layer of isolation that I have with namespaces, and it's not great for really developing some custom stuff. So what I need is a temporary, tiny Kubernetes cluster that I can create CRDs and Kubernetes operators and develop in. But in order to do that, we just had Alejandro show us this. And what does he need to do to create a new cluster for me? He would go to SUSE virtualization, and he'd say, all right, allocate 8 gigs of RAM, put an operating system on this machine. There's a whole bunch of overhead there, right? I haven't done any work yet, and we're already consuming 8 gigs of RAM. There's got to be a better way. So what we can do is let's really just focus on K3S for a minute. If we take K3S and we just put K3S inside of a container, we can get that thing down to under a gig in size, right? And then we can actually spin that up, and we will wind up with a full running cluster well under a gig of RAM. So that's great, much less resources. I'm no longer pre-allocating 8 gigs of RAM for VMs or anything like that, and I can do my development. Now we're talking Kubernetes, right? So what do we want to do? We're going to take that container, throw it inside of a pod, and now we need a Kubernetes cluster to run this on, right? So we can run this on the main Kubernetes cluster that we've been running all along. So we actually have a Kubernetes cluster running inside of another Kubernetes cluster in less than a gig of RAM. And so what really becomes cool is when we zoom in on this Kubernetes cluster, I've got a whole bunch of tiny little isolated Kubernetes clusters that can come and go throughout the day. My developers can develop that custom code. It doesn't affect anyone. I really get the best of both worlds, right? So that's great. I can have a ton of these different Kubernetes clusters. So I've got Kubernetes running on top of Kubernetes clusters with virtual clusters. But then what's that cluster running on? Of course, another Kubernetes cluster, right? So it's Kubernetes clusters all the way down. This is one of the cool things that we just announced was SUSE virtual clusters. What I'd like to do is, Al, can we actually see what this thing looks like? So this is very early preview. I really want to thank the developers. They just got a UI for us last week so that we could show this, but this is some of the funnest code that we've been playing with for the past week.
All right, yeah, let's click Create and choose K through K as our provider. Once we choose K through K as our provider, in our Ampere Galaxy host cluster, we're going to click Install K through K, which is going to set up the K through K controller, which is going to allow us to manage and install our virtual clusters. And then we're going to call this a SUSECON25, and just set the virtual cluster servers to 3 for a highly available cluster. And that's really all we have to do. We'll go ahead and click Create. While that's creating, what we can do is go into the host cluster and then choose the K through K system and K through K SUSECON25 namespaces and click on workloads. And that'll give us our SUSECON25 server pods that are creating our virtual cluster.
Cool. So in a couple minutes, that virtual cluster will completely be up and spinning. That's awesome, but you know what my next question is going to be.
Can we observe it?
Observe.
All right.
Yes, we can.
Yes, we can.
So let's take a look at virtual clusters, because Al created the nice one. We go into a hamburger menu, and what we select is clusters. Why? Because virtual clusters are, like Aaron explained, just clusters. So we see actually a bunch of them running, and we see that nice SUSECON cluster at the bottom, which is actually in a green state. You saw also last year's SUSECON cluster, which was a real one, but this is a virtual one. So let's get into that to actually see whether it's any different from what we normally see. And again, it's just a cluster. It's got its cluster metadata, its cluster-related resources, events happening. We see the nodes in the cluster, which is actually one. Sounds great, right? We've got one node in that cluster at least. Resource usage, Kubernetes CPU and memory, all of those are there. Let's take a look at the related resource. We see a bunch of pods running in this cluster. So we see the SUSE observability agent, core DNS, great, and we see cattle and rancher and fleet, meaning this cluster is actually managed by SUSE Rancher Prime. That's great. So let's take a slightly different perspective on this cluster, because how is it actually running? Go into our hamburger menu and actually look at the servers of Kubernetes virtual clusters. And we see that there's actually 3 different servers running, as Al correctly actually created. A server 0, a server 1, and a server 2. And we see they're actually hosted in our far edge cluster. They hosted in a namespace, and they're all part of this virtual cluster. So let's dive into one of these servers. And what we see is this server, it's a pod. It's not a real thing, it's just a workload in that host cluster. We see all of its pod metadata, we see the pod events, we see the logs of this pod, and we see metrics. And if we go into the log, if we scroll down indeed, we see the metrics. Now, let's have a look at what this pod is actually doing, because we want to see, right? So we can go into the logs, and what we see is actually all of the standard Kubernetes K3s logs that are captured by this pod. And we see it's actually K3s, right? It says starting K3s 132.1, which is great. It's a cluster running in a cluster. Amazing. Let's take another perspective. We see all of the events also captured. We see the containers were started, the pods were running, we created some persistent volumes. So everything you need to actually observe a virtual cluster is there. But how is this actually built up? Because it sounds very complex, right? So to do that, we go into our action menu and we want to show the virtual cluster topology, because that's what actually shows you how it's built up. And what we see at the bottom is we have this machine, part of our far edge cluster, that's hosting 3 K3K clusters, the server 0, server 1, and server 2, which are those pods that we just were looking at. Those actually expose a virtual node. So not a real node, a virtual node. And on that node, there's actually a bunch of virtual pods running. So we see those pods that we just mentioned before. And what we see is each of these pods is not actually running in that virtual node. It's running on that host cluster, so they're mirrored on the bottom layer. So while we think they're actually part of that virtual cluster, they're actually hosted on the host cluster. So it's a great technology, actually, which helps you isolate necessities, but we're still hosted on that cluster.
All right, we're going to speed it up here. So back to the slides a little bit. We're going to dig into that application. We're talking about SAP Edge Integration Cell. We're talking about the large language model and a custom application in the middle. But what I really need to run this is a GPU. And so, Al, I would love to ask if you can provision a virtual GPU in a cluster for us to use.
You got it.
Let's go back to this.
Right, so let me have my screen here. Perfect, so what we'll do is modify our current SUSECON SUSE AI cluster. And what we do is simply click Edit Config. Then we scroll down into the Show Advanced section. And we click Add in our vGPU section. I have several already provisioned in SUSE virtualization. All I have to do is allocate them. I will choose this one that's 4Q. That's specific for CUDA. And we just click Save.
And that's it.
Done.
That's it.
Awesome.
Thank-
All right, so those other components we were talking about, right? So we've got now the large language model and something to run inference on top of it.
So we've got now a cluster with a GPU in it, right? Al just allocated that for us. We needed Olama, no problem getting Olama. We just pointed to the application collection version of Olama. We got that secure, reliable version. But now let's talk about AI security, right? You and I stay on top of AI big time, and
well, there's a lot of things out there, and a lot of things that people are talking about, and a lot of big events, and we've really sought deeply some things. So let me see if I can point out a little bit of the application here for the security piece.
okay.
All right, so this is our cluster, Aaron. And we see on the left-hand side, you've got your AI reasoning agent. This is that custom application that we've built. It's going out, it's deployed in the cluster. It's actually going out to several API services, right? So if you go into SUSE Security, you can see that there's the actual application. We can take a look at the locations it's going out to consume some of these API resources. Notice anything?
So that's the key. It automatically profiled our application, and it's seeing that our application's talking to DeepSeek and to various other models, which is probably not allowed by our corporate policy.
Right, so NuVector is always on. What's nice is our security team gave us, remember Aaron talked about a CRD. So this is going in, we're gonna take a CRD, which is a custom resource definition for the security. We're actually gonna pull that security in as code, and this is a known good list of the URLs that we can go to. Corporate policy said we can't go out to DeepSeek, so we're not gonna include that in the list. We'll go ahead and import that. You'll see that it's imported these rules, and it has a known good list of URLs. Once we've applied that, we can go back into SUSE Security and hit refresh. At that point, you'll see that it has put the application into protect mode. Remember, Aaron said it's always on, always learning. Now that it's in protect mode, it will keep from learning any new resources, whether those are services or end connections on the network. Here you can see the processes that are running and the network rules. The last thing we'll do is take those things that it learned earlier when it was always learning. We're going to actually delete those DNS rules, and then we'll refresh the network. So let's scroll to the bottom. And that one that we want, you'd think it would be the bottom one. It's actually 10153, the one above it. It's going to external AnyPort SSL applications. So click 10153. And then on the right-hand side, you'll see a little trash can. Yeah. We'll hit delete. It'll say, are you sure? Go ahead and say OK, and then we'll have to save this so it'll re-affect the policy. Click Save, deploy that policy, and now we should have different things that we see from the network traffic. So we can go back to the view, click Clear, it'll clear out what it knew before, hit refresh on this screen, and we should see, okay, so there's the AI reasoning. You see it's green, it's in protect mode, and then click on the external traffic, and we'll see that a couple things are being denied. So this is a way to put boundaries around your AI applications that you're deploying. And then go ahead and look at the security events, and any exception to those rules is logged, which means that you can have complete proof that this is actually working and let people know, yes, it's possible to secure the edges. So,
Cool.
Finally.
So can we observe?
Yes, we can.
can. Pull up the screen. So we're actually looking at one of the nodes now that has a GPU attached to it. So, and what we see is we see a bunch of metrics, but if we go into our metrics tab, we actually see GPU power consumption and GPU temperature immediately monitored and observed by SUSE observability. So we see it over time and current. If we go down, we also see the frame buffer memory use, GPU utilization, tensor core utilization, which is great, right? We see the GPU, but can we see more? Yes. We go into our GenAI observability. We actually want to look at our LLM system. So we look at Olama that was deployed, and what we can see immediately on the dashboard is we're actually consuming tokens from the LLM, but we also see that this LLM is actually costing us money. So it's right back at where Rick from IDC actually said, you need to be able to observe your AI because it is costing you money. And you can only see that with SUSE observability.
So you can see it.
You can.
And it's important because tokens, the currency of use in large language models, there's input tokens, there's output tokens. All of those tokens you can equate to a cost, right?
Yeah, and those tokens, they're just words, right?
Split up words, they could be sentences, it depends on the language, but that's all part of why it's important to see what's happening with your AI application. To know when you need to scale it, know how it's affected by different models, the changes in models, your prompts that you're pushing in, whether you're efficient or not. This is expensive hardware. Having that visibility is key to be able to run AI applications efficiently.
So that's why I need to pay for any LLM out in the internet, basically.
You can actually run all of this privately, and that's why SUSE AI is so important. The ability to run this on your hardware, keep your data inside, and be able to plug the holes around it in case there's something inside that you don't know. So this is important. What we'd like to do is probably wrap up Demopalooza because we're a little over time.
Of course.
We want to urge you to come to the technology showcase. Ask us about all of these things. Have some deep conversations. We're ready to share what we know and this ever-changing journey that is expensive. And you want to be able to maximize those costs, especially when you're at the International SUSE station. So we're ready for launch.
Yep, thanks a lot for attending.
I think we had John Pugh on a remote session. Wasn't he on vacation?
Yeah, he
Some
was actually on vacation. That's
lunar holiday. Hey, John, how are things? What's the view of Demopalooza this year from your vantage point? I think he says it's all systems go.
yeah.